All right, welcome to the team presentation for Adam Frank, Ryan Hafen, and John Stewart. We are working on Stuck on an Island as our team project, and we're just going to go over some of the things that we've learned so far as we've been working on this project. So the first thing that we're going to go over is the 7 steps to function development. The first step is to clearly define the problem. The problem that we are going to go over is how to calculate the remaining um, needed vines to build a completed raft to escape our island. That is our problem. So the next step will be to go ahead and to create a test matrix. Um, the test matrix has the inputs that are required and the output that you can see here. Uh, like as I said, this is for the calc vines needed, valid entries, invalid entries, and our boundaries. So our valid entries are going to be 50 and 100. 50 for the current inventory amount and 100 for required. Invalid is going to be negative on the amount in inventory and -1, and the amount required on our second one is -1. The last one for our invalid is 101 for our amount in the inventory. Our boundaries are 100 is always going to be required, and our limits on our amounts in inventory are 0 and 100. Um, so this is the test matrix that we created. The values that we should expect are 50. We should get a -1 for an invalid on all 3 of these invalids. Our boundaries, we should get a 0 and a 0. Errors are going to be inventory is negative, required is negative, and amount is too high. So the next step is to outline, step 3 is to outline the solution. That's our algorithm right here. Calc, to get the calc needed, we need to pass in the variable amount in inventory, amount required, and that's going to be returned as a double. Then we begin. So if our amount inventory is less than 100 or inventory is greater than 100, sorry, if our inventory amount is less than 0 or our inventory is greater than 100, then return -1. If our amount required is less than 100, then return -1. Your vines equals amount required minus inventory. So that's our algorithm. So then we jump into where we create this, and it's in our build control. So here is our function right here. So this is the next step is to translate the algorithm into code. So we have our public double calc vine needed. We have our passing in a double amount in inventory and a double for amount required. So the first check right here is an if statement that verifies if the amount in inventory is greater than, less than 0, or if our amount in inventory is greater than 100. And if either of those is true, then it returns a -1. Our next check is to verify that our amount required is valid. So if it's less than 0 or greater than 100, it returns a -1. Then it goes into our calculation. So it creates the double vines needed, and it does our calculation amount required minus our amount in inventory, and it returns our vines needed. And the last step is the next step is to run our test cases, which we will go over a little bit later on how to do our test cases. The next step is to deploy our changes to our repository, which is just using the GitHub function to return that to our repository. So that is everything that you need to do for our 7 steps of function development. Thank you. All right, we're going to go over the um, 4 select statements. The first one being the if statement, which is the most simple. Uh, the first part is the if, obviously, and then the condition, and then the result. In this one, we are checking to see if the vines in inventory equals the vines required. If it does, then it prints a message saying that all the vines, that you have all the vines needed. If this is false, if the inventory does not equal required, then it skips this step and proceeds on. The next one we're going to look at is the uh, nested if statement, which is very similar. It's just a if statement inside of another if statement. So the first if statement is going to check if our vines in our inventory equal the required amount. If that is true, then it goes down into the next step, which is the wood in inventory equals the wood required. If that is true, then it prints that you have everything required, and it goes, and in this case, it would end the game. If that is false, then it exits out. So those are the 2 basic if statements that are used to do the selections.
Hi, this is Adam, and this is going to talk about the switch case select statement. A switch statement allows the developer to code many options in one block of code and gives the developer and the user an ease of readability with the code. The components of a switch case is the test here at the beginning where you have switch, and then in this case we have menu option. Menu option is what's being set before the switch happens. We're setting it using this to uppercase so that when the user inputs a letter for this menu option, it can be either uppercase or lowercase, and this to uppercase will set the letter to the uppercase. So we only have to test for uppercase letters. Each switch is made up of a case statement, and if the case statement evaluates to true, then there's a block of code that executes, and then a break. A break will exit the switch and allow the program to move forward using the input that is captured. In this instance, we have many cases where we can test for different letters of our menu. And then at the end, we have a default, and you should always have a default in order to error trap and to make sure that the user picks a letter that we want them to pick. So if they did not pick any of these letters that we've outlined in our case statements, the default will tell them that they have an invalid selection and to try again. This switch is a good way to, again, code many different options for a menu, as well as error trap and make sure that they choose a specific letter that we want them to choose. One of the issues that developers will run into when they're using a switch case would be that they forget the break. And so their switch will execute properly. And if this case we had the user select the letter C, it would print you've picked up a canned food item, and then the break would not happen because it's been left out or omitted. Or that means that the switch would continue to just be in a limbo mode until we were able to debug and check for the break. You can think of the switch case as a modified if-else statement. So instead of saying if something, do something, else something, do something else, in this case we just have a switch where it evaluates an option and then chooses a case that we've predefined in our code and allows the user to choose a menu option as we see in this case. And from a developer standpoint, again, it's easy to read, it's easy to debug, and it's easy to follow along.
Hi, this is John Stewart. I'm with Ryan and Adam, and I am discussing right now the if-else-if statement. If-else-if is a multi-conditional statement. What it allows you to do is to select between more than just two options, which are basically like the binary options, either on or off or yes or no. This allows you to select multiple options. It allows you to choose between, well, let's be honest, an excellent example is a menu. The if-else-if allows you to choose: if this condition exists, then do this. Else, do this if this condition exists. Else, do this. So it gives you a choice. It gives you an option here. As you can see in this code, in this example, by the way, this example comes from the main view of the program that is being written for Stuck on an Island. In this case, the if-else-if statement, as you can see, is towards the bottom of the section of code that I have displayed here. At the top, you see the menu. Here's the menu. The option for the menu is right here. We've got Start New Game, which is N. We've got G and H, S, Q, and any other option then would result in an invalid selection. You can see here the if-else-if statement right here. And what that allows you to do is it gives you instructions to select between the N, G, H, S, or Q. Anything else is going to be given an invalid message, and they are going to be instructed to choose from one of those. Once the user chooses from one of those, then the game will continue. And so the value of the if-else-if statement is that it allows you to make a selection from multiple choices. You are not stuck with just the binary choice of on, off, or just yes or no. You do have an option between multiple choices, and then your game will be able to continue at that point.
Hi, this is going to be evaluating the unit test package. We use a unit test package in order to test our code and to evaluate the algorithm that we've written to see that the actual Java code that we've created in our 7 steps actually outputs the result that we expect it to based on our paper testing. So we have different functions in a block of code, and this allows the developer to input values to make sure that we get out of our code what we expect. In this example code, we have a test case for this function called test calc wood needed. And this would be used in our island game, where we're testing to see how much wood we'll need to build a raft. And so we have a couple of variables here, double amount inventory and double amount required. We've set those values as 50 and 100. And then we're building our control. We expect a result here of 50, and then we actually calculate a result using the inputs. And at the end, we use this assert equals to test the expected result versus the result, and there should be no difference when it comes back. And so when you run this in NetBeans, it allows you to see with a pass or fail what values are returned. And this is good in many ways, so that you can test your blocks of code. You can test your algorithms to make sure that they're giving you the values back that you would hope that they're giving you based on the planning and preparation that you've done through the 7 steps of development and creating a paper test.
Hi, this is John Stewart, and as part of the group with Adam and Ryan, I am defining scope. Scope refers to the life cycle of the variable. It is a variable can be called at different stages in the class, and within that class, it could be called at the beginning, which would make it available to the entire class, to every function. If that variable is called within that function, then it is only available to that section of the function in which it was called. And in this case, well, the scope of that particular variable is only valid as long as that variable is being called. Once that call is no longer valid, then that particular scope, or that particular variable will be gone, which would be the scope of that variable. It is only as good as the time that it is actually being called. On our sample code, we have a variable. As you can see, I have marked it in red here. It is the good idea, and this variable is called within that function, and it only has a life cycle as long as it takes for the user to make a decision and then choose the outcome, whether they want 1 or 2, and being able to move on to the next class that they're moving to.
All right, I'm going to go over the lifespan of variables. Right here is our block of code. Uh, there are a few variables that we have in here. We're creating a scanner called keyboard. We are creating a string called value, and then we are creating a valid variable called valid and setting that to false. Now the lifespan of these variables are only within this scope of block right here. Once we leave this block, then they are removed from memory. But the interesting thing is during this while, you can see that we call valid each time. So that inside this block, these value or these variables, no matter how many times we loop through this block, those variables are still there in memory, still being used, still being updated. So as long as we are within this outer side block of for this scope, then these variables are valid and are in memory. Once we leave this block, then they are removed from memory.
Hi, we're going to talk about pass by value in this slide. The other way to pass information is by reference, and that is covered in another section. This section is about passing by value. You can see in this example here we have a function where we set some variables. We have an Idaho rate of 0.06, we have a retail price of 1.25, and then we call a function get total cost where we insert retail price, the number 10, that is our quantity, and then the Idaho rate. So we have 0.06 and 1.25 passed by value through these variables, and then in memory, when we call the get total cost function and actually calculate, it's going to take those retail price and call it a unit price, and the number 10, which is now the quantity, and the Idaho rate, which is the tax rate, and do our math where we multiply unit price times quantity. The tax is the extended price times the tax rate, and then the total cost is the extended price plus the tax, and then the total cost is returned back to the call function. This is a use of directly passing data from one function to another by their values. It's called a primitive values being passed to a function is another way to call it. And the actual values are being called and passed into the function. This is a simple way to pass data in and out of functions to return information. The other way is passed by reference, where we're actually referencing a location in the memory. And again, that is covered in another section.
All right, I'm going to go over the pass by reference. We're going to just review this little block of code right here. We have a view, as you can see over here, our wreckage inventory view. That is what we're calling right here. So we are creating an instance of this object. So when we pass by reference, we are referring to an object which is stored, which is created, and then we will refer right here to that the variable name that we give it is right here. We refer to the not the values, but we refer to the actual location of memory when we refer to this variable here. That is how we are passing by reference and not by value.